lesson 8.1. So today we're going to start learning the rules for multiplying with exponents. And remember, just like yesterday, we're going to leave our answers in simplest fraction form, not in decimal form. So if you happen to be using your calculator and you get a decimal form answer, be sure you go back and do the math frac on the calculator and get a fraction form answer. You can put the problems in the calculator that have all numbers. You can do that, and I don't mind if you do that. But the ones with letters, you cannot put those in the calculator, so you still have to learn these processes. Okay, so what we're going to have to do today is we're going to have to be aware of the exponents that have the same base. Now, once again, here are all the rules. I'm not going to read them out to you right now because it won't make any sense until we do some problems. Okay, but the thing we have to remember, the main thing today is we have to do these rules to the exponents of the bases that are the same. Okay, so on your paper, number 1 is already worked out for you, and I've taken some notes for you there. So look up at the screen and let me work it for you. First thing we're going to do is we're going to group together the things that are like bases. So what do these parentheses mean? Multiply. And when the letters are right next to each other, what does that mean? Multiply. And when the number is right next to a letter, what does that mean? Multiply. So this problem, there's no adding and subtracting in the base parts. Okay, so just think about all this stuff being multiplied together. And you can multiply things in any order. So we're going to regroup this stuff. I'm going to put all the number parts in the front. Okay, so I'm going to have -2 times 5 times 4. That's all the number parts. I've already done that for you on your paper. Just keep watching. Now remember, that's multiplying. It's not any adding or subtracting. Now I'm going to start grouping the letters together. So I'm going to put all the A's together. Okay, so there's my A's. So now I'm going to say times A to the 8, times A to the 5, times A to the 7. And then I'm going to put the B's together. So here's the B and the B, times B squared, times B to the 4. And now there's one other little thing hiding there. You see it? The D. I almost forgot the D, so it's a good thing I was highlighting because there's my D. So at the end, I'm going to put times B. Now, with the parts that have the like bases, for the numbers, we do the normal thing that we would do with the numbers. So what would we normally do with those numbers right there? Multiply them. So when we multiply them together, we get -40. Now, with the letter parts, here's what we do. This is the rule. We're going to add the exponents. Now, remember I said there's no adding or subtracting in the bases, in the base parts of this problem, but we're going to add the exponents. So we've got 8 plus 5 plus 7. What's 8 plus 5 plus 7? And so we bring down A to the 20. Now here's our B parts. And we do the same thing only with the parts that are like bases, right? We do the same thing again. So 2 plus 4 is 6. So we bring down B to the what? 6. And then the D doesn't have anything to go with it, so do we throw him away? No, we just bring him down. And no, we don't have to put the dot between the letters because when the letters are right next to each other, that means times. If you want to put the dot between the letters, you can. Now, let's take a look at why this works that way. I'm going to do the B part because it's not as big. Okay, if I have B squared and I expand that out, it means B times B, right? Is that B squared? If I have B to the 4th and I expand that out, what does that mean? Right. write B times B times B times B. Now, if I take all those and I squish them back together, I have what? B to the 6th. So here was the 2, and here was the 4. So 2 plus 4 gives me the 6. And remember, this adding part is only for the exponents. Don't start adding the bases. Look at these numbers right here that I'm pointing out. Don't start adding those numbers. You would never do that before. They're numbers, big numbers, bases. You would multiply them. So don't start doing wacky stuff that you've never done before. Okay, let's do number 2 together. Okay, let's pull out all the pieces that go together. What number is with this first parenthesis part? The first parenthesis part. Could we squeeze a 1? Okay, so we've got 1 times 3, basically, for the number part. Okay, let's pull out our x's. For the x's, we have x to the 8. Here, I'll highlight again. We got x to the 8 and x to the negative 5. Now, yesterday we looked at negative exponents and what to do with those, but we're not going to do anything until the very end with the negative exponents. And then we have y to the negative 5 and y to the 6 times y to the negative 5 times y to the 6. Now, remember, we're only going to add the exponents of the like bases, which means for the x's and the y's. What are we going to do with the 1 and the 3? Just multiply like you normally would. So we have 3. Now, for the x's, we have 8 plus negative 5. What is 8 plus negative 5? 3. So that negative part kind of disappeared all by itself. We didn't have to do anything to it. So we have x to the 3rd. Now, for the y, we have negative 5 plus 6, which is what? 1. Very good. So y to the 1. Do I have to put to the 1? No, we don't always have to put to the 1, but when there's not an exponent, we know that it is a 1. Okay, any questions so far? Alrighty, number 3 is already worked out, so look up and watch me explain. This is a new kind of problem. I want you to notice on this one there's a parenthesis at the end, and then there's another exponent outside of the parenthesis. So when the exponent is right next to the parenthesis, this is the other rule that we're going to follow today. We take this exponent that's outside of the parenthesis, and it's like distributing. It's not called distributing, but it's like that. We're going to multiply this exponent to all the exponents inside the parenthesis. And remember, when you don't see an exponent, what is it? A 1. So what's the exponent for the 5? A 1. And that's my caution on this problem. We're going to say 2 times 1, not 2 times 5. Okay? 2 times 1, not 2 times 5. Then we're going to say 2 times 4, 2 times 6, and 2 times 3. Okay, so 5 to the 2 times 1 is 2. The to the 2 times 4, 8. W 2 times 6, 12. X 2 times 3, 6. Very good. Now there's still one thing that has to be simplified in this problem. And I may have forgot to write that down on your notes for you, so let's do it correctly right now. I think I didn't do it right on your notes. Is this what's written on your notes and circled? Okay, let's do this correctly. What is 5 squared? 25. So write down 25. You guys write this down. 25, v to the 8, w to the 12, x to the 6. And then circle that one. That's the correct answer. Questions? Okay, let's do number 4 together. So we've got on number 4, we've got this parenthesis at the end with an exponent outside the parenthesis. It's like distributing. It's not called distributing, but it's like that. we're going to multiply the negative 2. Y'all see that's a negative 2 on that one? Times all the exponents. Now, when you don't see an exponent, put a 1 so you don't accidentally do it wrong. So where do we need to squeeze 1s on this problem? After the negative 8, we're going to put a 1. Good. And after the y, we're going to put a 1. And then we're going to multiply negative 2 times those 3 exponents. Do not multiply an exponent times a base. Okay, so we've got negative 8. Put that in parentheses. 1 times negative 2 is what? Negative 2. So negative 8 in parentheses, and the exponent is negative 2. We'll have to deal with that in just a minute. Okay, then we have x to the 5 times negative 2 is what? Negative 10. And then y, okay, 1 times negative 2 is negative 2. Now this problem, the negatives didn't go away like on example 2. So we're going to have to deal with these negative exponents. This is where the lesson from yesterday comes in. Okay, so remember what we did. We put an equal sign, and we draw a bar. We go through letter by letter, number by number, decide if it stays where it is or if you flip it over. Okay, the negative 8, does it stay where it is or do you flip it over? You flip it over. Now, do you flip it over because it's a negative 8? No, you flip it because the exponent's negative. Very good. So negative 8 comes to the bottom. The exponent follows and turns positive. Question? Simplify it to what? In a minute we will. No, because it's not because of the negative exponent. You have to get the exponent positive before you simplify it. So we will do that in just a minute. Did y'all hear that question? He said, can we not go ahead and simplify that? You want to wait till all your exponents are positive before you simplify. Okay, let's go to the next one. The x. Does it stay where it is or flip it? Flip it. So we put x. The exponent follows it and turns positive. How about the y? Flip it so it goes on bottom, y squared. Now we have a blank numerator. Can we leave a numerator blank? We put a 1 there. Very good. Now we go back and simplify this part. Just like on number 3, I forgot to do that. Don't forget to do that. So we've got 1 over, now what is negative 8 in parentheses squared? Is it 64 or negative 64? It is 64, very good. X to the 10, y squared. And there's your final answer. Now number 5 has a little bit of everything in it. We've got some ending parentheses with exponents outside. We've got 2 of those. Then we're going to have some bases that will be similar. So we'll have to add the exponents after that. Okay, so the first thing we're going to do is look for places that we need to put 1s for exponents. Do you see any places that we need to put 1s for exponents? After the 5 and after the negative 2. Very good. Now we're going to multiply exponents. Do not multiply an exponent times a base. Multiply exponents. So we're going to have a 5 times 2 to the 2 times 1, which is 2. X to the 2 times negative 3, which is negative 6. Very good. Y to the 2 times 6, which is 12. Very good. Now, I am going to put a dot right here just so I don't forget that this next part is multiplied also, because there's a number coming up next. So I'm going to put a dot so you be sure and remember that it's times, not add or subtract. Okay, so I'm going to take the 3, I'm going to multiply, multiply, multiply. Okay, so I've got negative 2. Now the exponent is 1, so So 1 times 3, 3. Then I have x again. The exponent is 5. 5 times 3 is 15. Good. And then I've got y again. Negative 7 times 3, negative 21. Okay, now this problem looks a lot like number 1, doesn't it? Now that we've done this first step, does it look a lot like number 1? So now what do we need to do? We need to group up the like pieces. Now, can we take a shortcut, or do we need to write it out long ways like number 1? Here's what I'm going to suggest for the shortcut. If you don't like it, we can do it the long way. I'm going to say, okay, this, I'm going to underline this, and what goes with this? This one goes with it. So I'm going to put those together on my calculator. Can you do that? Push your calculator. 5 squared times, now don't add or subtract, do times, put negative 2 in parentheses, exponent of 3. And what does it say? What does your calculator say? Negative 200. If you did not get negative 200, let me help you. Does anyone need help? Okay, let's look on my calculator. Okay, let's do it here. So we need 5 squared times, and then we need parentheses, negative 2. Here's your exponent button. And we want an exponent of 3, and then we're done. Enter negative 200. Got it now? Okay. Anybody else? Now, what else goes together on this problem? The x parts go together. Very good. So let's underline those twice. So for the x's, we've got negative 6 plus 15. What's negative 6 plus 15? 9. So we have x to the 9. That negative took care of itself, didn't it? We didn't have to do any flipping or anything. Okay, what else do we have that goes together? The y's. Let's underline those 3 times. Okay, so for the y's, we have 12 plus negative 21. What's 12 plus negative 21? Negative 9. So now we have y to the negative 9. That negative didn't take care of itself, so now we have to use what we learned in yesterday's lesson, and we have to finish up this problem. Okay, so put an equal and a bar. Go number by number, letter by letter, decide does it stay where it is or do you flip it over. Negative 200 stays. Negative 200 is okay. If the exponent was negative 200, would that be okay? No. Exponents can't be negative, but the bases can be negative. Okay, how about the x? Did we leave it where it is or flip it? Stays where it is, x to the 9. How about the y? Flip it over and it becomes y to the 9. Very good. And there is your final answer. Is there a question?